Something just came in from another star system, third time in history, July 1st, 2025, Chilean telescope, object designation, 3I Atlas, moving backward through our solar system at 61 kilometers per second, 137,000 miles per hour, fast enough to escape the sun forever. But here's what has astronomers losing sleep. Its orbit lies 5 degrees from Earth's plane, retrograde motion on a near-perfect planetary alignment. Statistical probability, 0.2%. You roll those dice 1,000 times and watch this happen twice. 2 out of 1,000. That's what we're staring at right now. So, what is 3I Atlas? Where did it come from? And why is its path through our system so precise it makes veteran astrophysicists start using words like designed? If you value documented astronomy and interstellar object research like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from Wikipedia's continuously updated 3I Atlas article, last modified October 23, 2025, at 12 hours ago, NASA's Jet Propulsion Laboratory, Small Body Database, accessed October 23, 2025, the Royal Astronomical Society's National Astronomy Meeting Proceedings from Durham, July 25, Avi Loeb's statistical analysis published in Medium on July 16, 2025, and peer-reviewed papers from ARXIV, including Hopkins and collaborators' Otauta High Oxford model published. July 25, the VLT Muse spectroscopy paper by Upatom and team from July 7, 2025, and the X-Shooter spectrum analysis published August 5, 2025, in Astronomy and Astrophysics. Now back to the information. Observatory code W68, 1:47 a.m. Universal Time. July 1st, magnitude 18 object, Serpens Cauda constellation, galactic plane, dense star field, temporary designation A11PL3Z, submitted to Minor Planet Center within minutes. Amateur astronomer Sam Dean later explains. 3. I wasn't discovered earlier because it was passing directly in front of the Milky Way's core. Too many stars, impossible to pick out a moving dot, but Atlas caught it. 4.51 astronomical units from the Sun, 3.5 AU from Earth, moving along the Sagittarius border, coming from the direction of our galaxy's center. Then Atlas's own archive shows June 25 through 29. Pre-covery goes back further. Weizmann Observatory, May 21, TESS satellite, May 7 through June 3. 6.4 AU out and already showing a coma, already active. 2 months before official discovery. Moving too fast. Hyperbolic trajectory confirmed within hours. Eccentricity, 6.137. Highest of any interstellar object ever recorded. 1I Oumuamua had 1.2. 2I Borisov had 3.4. This thing has 6. Trajectory looks almost straight. Coming in, swinging past, never coming back. 122 observations from 31 observatories in under 24 hours. Nordic Optical Telescope, David Jewett and Jane Liu. Clearly active. Diffuse coma confirmed. Deep Random Survey in Chile. Lowell Discovery Telescope in Arizona. Canada, France, Hawaii Telescope on Mauna Kea. All see the same thing. Marginal coma, 3 arc-second tail elongation. It's not an asteroid, it's a comet. Active and outgassing. 3.46 from Earth. Optical spectrum. 4,800 to 9,200 angstroms. Red coma. Spectral slope 18% per 1,000 angstroms. Redder than most solar system comets. Similar to trans-Neptunian objects. Similar to centaurs. Similar to D-type asteroids. Searching for gas. Carbon-2, amino radicals, cyanide, atomic oxygen. Nothing. No gas emissions detected. Coma appears entirely dusty. But it's a comet. Dust liberated somehow. No sublimation tracers yet. Thomas Puzia's team, 300 to 2,500 nanometers, full spectral range. Ultraviolet through near-infrared. Reflectance spectrum normalized at 550 nanometers. Moderately red slope confirmed. 18.59% per 1,000 angstroms in the 528 to 860 nanometer range. Matches Muse. Matches supernova integral field spectrograph data from Hawaii. Matches Gran Telescopio Canarias. Consistent across 4 independent telescopes. This is real. But the orbit, that's the puzzle screaming for attention. Inclination 175.114 degrees. Retrograde, moving opposite to every planet, yet only 5 degrees off the ecliptic. Earth orbits in a flat disk. Mars, Venus, Jupiter, all in that same plane. Billions of stars in interstellar space. Objects can arrive from any angle. Sphere of possibilities. Yet 3I comes in almost perfectly aligned with planetary orbits, but backward. Harvard astrophysicist Avi Loeb calculates the odds on July 16, 0.2% probability, not 2%. 2/10, 1 in 500 for alignment alone, but there's more. Hidden from terrestrial observation during closest approach, planetary encounters perfectly timed. Mars, flyby October 3rd, 0.19 AU, 28 million kilometers, 18 million miles. Venus encounter November 3rd, 0.65 AU, 97 million kilometers. Jupiter pass March 16th, 2026, 0.36 AU, 54 million kilometers, 33 million miles. Retrograde motion means relative velocities are massive. Psyche spacecraft closest approach, September 4th, 2025, 0.302 AU. Relative velocity 71.58 kilometers per second. Europa Clipper lines up with Ion tail end of October. JUICE mission best view November 4th, 0.428 AU. Relative velocity 98.42 kilometers per second. Loeb publishes another analysis August 9th. Planetary encounter timing. Combined probability 5/1000ths of 1%. Not 5%, not 0.5%. 5 1,000ths. 0.0005. Roll 10,000 dice. Watch this happen 5 times. Arrival perfectly timed for close Mars encounter. Venus next, then Jupiter. All within 7 months. Retrograde path means mothership scenario. Release probes, planets move into them, high relative velocity guaranteed. Earth hidden during perihelion by solar conjunction. Can't observe the closest approach, even if we wanted to. Royal Astronomical Society, National Astronomy Meeting, Durham. 3. I likely originated from Milky Way thick disk. Ancient stars orbiting above and below galactic plane. U velocity minus 51 kilometers per second. Moving away from galactic center relative to Sun. W velocity plus 18.5 kilometers per second. Moving upward through galactic plane. Vertical velocity unusually high compared to nearby stars. Thick disk population confirmed. Stars in that region? 7 to 14 billion years old. 68% confidence interval. Solar system is 4.6 billion years old. Halley's Comet, 4.6 billion. Every solar system comet we've ever seen, 4.6 billion maximum. 3, I could be 7.6 billion minimum. Could be 14 billion. 3 billion years older than our sun. 3 billion years older than Earth. Older than anything that ever formed here. Hopkins and team estimate 2/3 probability. 3, I predates our solar system, drifting through interstellar space since before the sun ignited. Chris Lintott, co-author, BBC Sky at night presenter. Object from a part of the galaxy we've never seen up close before. Broad agreement with Hopkins. Thick disk origin confirmed by multiple teams. Trajectory traced back through galactic dynamics. Can't identify parent star. Too much time. Billions of years of orbital mixing. Gravity assists from passing stars. Close encounters with nebulae. Velocity changes accumulate. Origin point lost to time. But the thick disk signature remains in the velocity vector. In the orbital inclination through the galaxy. In the steep path above and below the plane. 277 million miles from Earth. Teardrop-shaped dust cocoon. Nucleus size calculation. August 20th update. Upper limit 3.5 miles, 5.6 kilometers. Could be as small as 1,444 feet, 440 meters. Gemini North captures it July. Karen Meach leads observation. Institute for Astronomy, University of Hawaii. Compact coma visible. Most estimates settle around 10 kilometers diameter, larger than 2 I Borisov by factor of 10, potentially one of the largest interstellar objects ever detected. Yet discovered at magnitude 18, faint. If it's that big and that faint, either it's very dark or it's further than we think, or both. Multiple lines, strong signal, no iron. Faye one should be there. Nickel and iron come together in comets, always. Solar system comets show them in roughly equal amounts. Outgassing releases both. 3, I shows only nickel. August 21st, X-shooter measurement. Heliocentric distance 2.85 AU. Production rate log Q nickel equals 22.67 atoms per second, 4.6 grams per second, growing as it approaches. Steep heliocentric scaling. Nickel production proportional to R to the minus 8.43 power. Dramatic increase with solar heating. Steep scaling. Cn proportional to R to the minus 9.38 power, even steeper than nickel. VLT UVES observations, ultra-high resolution. R equals 35,000 to 80,000. No atomic oxygen. No carbon-2. No carbon-3. No amino radicals still. Carbon chain depleted. Most carbon chain depleted comet ever known. C2 to Cn ratio upper limit confirms it. Toxic volatile compound. Used in industrial metal refining. Never naturally observed in space until now. Hypothesis. Carbon monoxide reacts with nickel particles. forms nickel tetracarbonyl, low temperature process, releases into coma, sublimes, creates vapor signature. If true, explains nickel without iron. Iron doesn't form equivalent carbonyl under same conditions, chemical selectivity, industrial chemistry, and a comet from another star. Carbon dioxide, CO2 peaks. Carbon monoxide, CO peaks. All labeled, all clear. Gas composition finally mapped. Water ice present. CO2 driving early activity. CO contributing. Water sublimation increasing as it nears sun. Swift Observatory, July 31st, August 1st. Tentative detection. Water vapor. Hydroxyl radicals, O signature. Water ice grains sublimating beyond nucleus, 4,000 to 10,000 kilometers out. Ejected by CO2 and CO outgassing. Not direct nucleus sublimation yet. Distributed source. Near-infrared observations. Carbon dioxide coma extended. Radius, at least 348,000 kilometers, 216,000 miles. Only visible in near-infrared. Coma, much larger than optical observations, showed. Gas envelope massive, Hubble can't see it. Optical telescopes miss it. But it's there, wrapping the comet in an invisible cloud of carbon dioxide. As 3. I approach the sun, that cloud grows. Density increases, temperature rises, more sublimation, more outgassing, more activity. Pre-discovery via Rubin Observatory. Images, June 21st. Coma diameter 13,040 kilometers, 8,100 miles. July 2nd, 18,760 kilometers, 11,660 miles. Growth in 11 days. Activity ramping even at 4.5 AU. October 3rd, 2025. ESA Mars orbiters ready. Trace gas orbiter. Cassis camera. 5-second exposures. Comet 50,000 times fainter than normal targets. Images captured. Coma visible. Mars Express. HRSC camera. Omega spectrometer. SPICAM spectrometer. TGO Nomad spectrometer. Multiple instruments, all turned toward 3I. Distance 28 million kilometers from Mars. Northern Martian sky. High elevation from Mars surface. Perseverance rover location 18 degrees north. Could theoretically observe if bright enough. Mars orbiters succeed. TGO animation released. Fuzzy white dot moving downward. Coma clearly resolved despite distance. Success. Maximum speed 68 kilometers per second, 42 miles per second. Solar elongation drops below 30 degrees October 1st through November 9th. Equatorial regions only, just after sunset. Brief window, then solar conjunction. October 21st, 8 days before perihelion. Completely hidden. Behind, sun from Earth. No ground observations possible. GOES, 19 weather satellite, October 18th through 24th. Magnitude 12 limit. Brief detection window, then nothing. Mars orbiters only observers during peak activity. Post-perihelion, 0.428 AU. 5.24 times closer than Earth at that moment. Best view of active, 3I. Ultraviolet spectrographs. Twin instruments with NASA Europa Clipper. Coordination considered. Particle sensors. Cameras. Spectrometers. All active. 3I 6 days past perihelion. Maximum activity. Outgassing peak. Dust production peak. Tail formation peak. Juice positioned perfectly. Europa Clipper flies through ion tail trajectory late October. Charged particle encounter possible. Ion detectors ready. Plasma instruments active. Direct sampling of interstellar comet material. First time ever. Coming in hot. Inclination 175 degrees, yet only 5 degrees off ecliptic. Retrograde aligned. Arrival from southern celestial hemisphere. Opposite solar apex. Models predicted interstellar objects from solar apex. Direction sun and nearby stars move through galaxy. 3. I comes from opposite direction. Behind us. Catching us from behind while moving backward. Can't observe anything during most critical phase. Planetary encounters. Mars, Venus, Jupiter. All perfectly positioned. All within reach. All at high relative velocity due to retrograde motion. Timing probability 0.0005%. 1 in 200,000. Statistical analysis, Giuseppe Santaiurescia. September 8th, 2025. Combined probability calculation. Eccentricity approximately 6.14. Probability roughly 10% for values above 6. Inclination 175 degrees. Extreme retrograde. 5 degrees span in 180 degree range. Probability 2.8%. Perihelion 1.35. 6 AU. Range 0 to 5 AU observable. Within 0.01 AU. Probability 0.4%. Orbital angles. 3 angular parameters. Tolerance 0.1 degree each angle. Probability 0.1%. Independence assumption. Multiply probabilities. Total probability 1.12 times 10 to minus 9, 1 in billion. Not claiming alien spacecraft, analyzing what would be required if hypothetically artificial. July 7th paper posted, archive preprint server, size anomaly, detecting 20-kilometer object over 5-year survey period, probability 0.01% based on interstellar asteroid reservoir. Argues for comet, brightness from dust and gas plume, nucleus likely under 1 kilometer, but VLT Muse spectroscopy, no gas initially. Later studies confirm gas but depleted, dusty coma without expected gas signatures, contradiction, not quite fitting comet model, not fitting asteroid model. Something between, July 16th analysis, retrograde alignment, 0.2% probability, extremely rare, trajectory aligned with ecliptic, unusual but not impossible. August 9th paper, planetary encounters, combined timing, Arthur C. Clarke, rendezvous with Rama comparison. Cylindrical alien ship, 50 by 20 kilometers, 3 eye size estimates up to 10 kilometers, similar scale, Earth opposite Sun during perihelion, technological probe scenario, aware of observers on Earth, avoids peak observation window. Daryl Seligman leads first published study. Classical signatures of cometary activity demonstrated. Multiple telescopic observations, gas confirmed, water, carbon dioxide, carbon monoxide, cyanide, nickel, cometary composition. Chris Lintott criticizes speculation. Live science reports overwhelming consensus. Natural comet. Speculation distracts from legitimate research. Scott Manley, David Kipping. Statistical analysis, flaws identified. Loeb's calculations questioned. Selection bias, observation bias, discovery bias, but the numbers remain. Inclination 5 degrees from ecliptic. Retrograde motion, 0.2%. Planetary timing, 0.0005%. Combined orbital parameters, 1 in billion. Numbers don't lie. Interpretation debatable. November 11th, 8-inch telescope minimum. Magnitude 11 to 12. Amateur astronomers ready. Unistellar network. Citizen science. Image stacking techniques. Rapid motion compensation. Observations submitted. Minor Planet Center. Professional telescopes. Rubin Observatory. First look images. June 23rd, 2025. Legacy survey of space and time beginning. Expected 5 to 50 interstellar objects over 10 years. 3. My first real test case. Serendipitous imaging, June 21st through July 3rd. Science validation observations. Rubin would have discovered 3I 2 weeks earlier if operations started sooner. Next time, more warning, better preparation, longer observation window. Orbit takes 3. I almost 1 kiloparsec above galactic plane, 3 scale heights for thin disk, almost at thick disk scale height. Thick disk stars 7 to 14 billion years old, metal poor compared to Sun, lower heavy element abundance, different formation environment, different chemistry, different isotopic ratios, different volatile composition. Tests coming, spectroscopy refines, isotope ratios measured, deuterium to hydrogen, carbon 13 to carbon 12. Oxygen 18 to oxygen 16, nitrogen 15 to nitrogen 14. Each ratio tells formation story. Temperature during formation, pressure conditions, parent star metallicity, comparing with solar system values, seeing differences, confirming extrasolar origin chemically. Phase angle 7.7 to 22.4 degrees, heliocentric distance 3.9 to 2.6 AU, FORS 2 on VLT 8.2 meter. Alfosk on Nordic Optical Telescope, 2.56 meter. Fourier 2 on Bulgarian National Astronomical Observatory, Rosjan 2 meter. R-band observations. V-band additional. First, polarimetric study of 3I. Second, ever for interstellar object. 2I Borisov first. Negative polarization branch probed. Poorly explored. Dust properties, grain size distribution, composition indicators, alignment mechanisms, scattering properties. Comparing 3I with solar system comets. Different polarization behavior suggests different dust, different parent material, different formation history from another star, from another disk, from another time. Metal poor environment, water abundant. Carbon monoxide present, carbon dioxide present, volatile rich formation zone. Ice line position different, temperature gradient different, disk structure different. 3. Eye composition should reflect thick disk chemistry. Observations confirming. Water detected, carbon dioxide abundant, carbon monoxide present, cyanide found, organic molecules probable, dust red and organic rich, carbonaceous material, irradiated organics, complex carbon compounds. Exactly what thick disk model predicts. Hopkins wakes up July 2nd. Messages. 3I! Planned quiet Wednesday gone. Testing model real time. Brand new object, possibly ancient. Predictions holding. Water mass, fraction high. Composition matching. Origin confirmed. Validation complete. 269 million kilometers. 167 million miles. Magnitude dimming. Below 12. Fading. Solar elongation increasing. Moving away from Sun. Moving away from Earth. Speed unchanged. 58 kilometers per second relative velocity. Escaping solar system. Never returning. Virgo, constellation December. Leo next. Fading through background stars. Last observations. Final spectra. Ultimate measurements. Then gone. Back to interstellar space. Journey continues. Billions more years. Drifting through galaxy. Thick disk orbit. High inclination. Crossing galactic plane. Rising above. Falling below. Traveling between the stars. Until maybe another system. Another encounter. Another species watching. Another telescope capturing light. If any exist. If any notice. If any care. July 1st through November. 5 months. 30 plus telescopes. 4 continents. Space and ground. Optical and infrared. Ultraviolet and radio. Spectroscopy and photometry. Polarimetry and astrometry. Every technique. Every wavelength. Every instrument turned toward one moving dot. Third interstellar visitor ever confirmed. First from thick disk. First retrograde aligned. First with nickel emission without iron. First with such extreme eccentricity. First with such ancient age estimate. First with timing this precise. First that hides behind Sun during perihelion. First that encounters 3 planets in 7 months. First that raises questions this specific. 3. I-Atlas orbital parameters. Final update October 23. Eccentricity 6.137 plus or minus 0.0006. Perihelion 1.36 AU plus or minus 0.01. Inclination 175.114 degrees. Argument of perihelion 287 degrees. A longitude of ascending node 86 degrees. Perihelion passage. October 29, 11:47, universal time plus or minus 1 minute. 3 sigma, uncertainty 3 minutes. Trajectory known precisely. Path calculated exactly. Future position predicted accurately. Orbital mechanics confirmed. Newton still works. Gravity still universal. Hyperbolic escape verified. One-way trip confirmed. Interstellar origin certain. Chemical composition emerging. Thick disk signature strong. Age estimate 7 to 14 billion years. 68% confidence. 1 in 500. 0.0005% timing. 1 in 200,000. Combined 1 in billion. Natural selection operates in astronomy too. We only discover what passes near Earth. We only observe what's bright enough. We only study what arrives when telescopes point correct direction. But 3. I wasn't selected. 3. I selected us. Came from behind. Arrived during commission of most sensitive survey telescope. Timed encounter with multiple planets. Positioned itself for Mars orbiter observation when Earth can't see. Hid during peak activity behind Sun. Maximum inconvenience for ground observation. Maximum convenience for spacecraft already in position. Coincidence probability calculable. Weather meaningful different question. Thick disk population. 7 to 14 billion years old. Formed when universe younger. Milky Way different. Galaxy more active, more mergers, more collisions, more ejections, more interstellar objects generated. 3. I survivor of ancient processes. Witness to galactic evolution. Time capsule from cosmic noon. Epoch when star formation peaked. When galaxies collided frequently. When intergalactic medium denser. When conditions different. 3. I formed then. Ejected then. Traveling since. Watching galaxy evolve. Seeing spiral arms form. Observing solar system birth. Passing nearby as Earth cooled. As life emerged. As consciousness developed. As technology arose. Arriving now. July 1st, 2025. When we can finally see it. When we can finally measure it. When we can finally ask what it means. Arrives Jupiter April 2030. 3. I encounters its ion tail trajectory October 25. Particle streaming, plasma flowing, charged dust escaping, Clipper instruments detect, maybe, possibly, hopefully, direct sampling interstellar material. First contact with ancient thick disk matter, atoms older than Sun, molecules predating solar system, water from another star, carbon dioxide from extinct disk, organics from vanished nebula, 1 spacecraft, 1 trajectory, 1 alignment. Plasma detectors ready, ion sensors active. Mass spectrometer waiting. October 25 encounter, 3I minus 4 days from perihelion, maximum outgassing, peak particle production, tail fully developed, clipper flies through, samples, measures, records, data beams to Earth. Scientists analyze, world learns. Ancient visitors' chemistry revealed. Interpretation varies. Consensus, natural. Probability low, but non-zero. Universe large. Objects numerous. Rare events happen. 1 in billion occurs billions of times when sample large enough. Milky Way contains billions of stars. Thick disk billions of years old. Countless ejections. Countless interstellar objects. Countless random trajectories. One eventually arrives, retrograde aligned. We see that one. Selection bias, observation bias, discovery bias, or maybe something else. Maybe question poorly framed, maybe probability calculation incomplete. Maybe we're missing something. Passing in front of galactic center, dense star field, millions of stars, one moving dot, impossible to distinguish. Until emerged from background, until reached less crowded field, until Atlas caught it, July 1st. Rio Hurtado, discovery announcement, July 2nd. Mobilization, immediate. Telescopes worldwide. Response coordinated. Observations shared. Data pooled. Science collaborative. 3, I belongs to everyone. 3rd, interstellar visitor. 3rd chance. 3rd opportunity. Learning more. Understanding better. Preparing next time. Rubin Observatory. Start soon. 5 to 50 detections predicted. Next decade. More visitors. More measurements. More questions. More answers, maybe. Multiple instruments, UV spectrographs, plasma detectors, dust analyzers, all active, all pointed, all recording. November 4th, JUICE observes, best view post-perihelion, ultraviolet spectroscopy, gas production measured, composition refined, isotope ratios attempted, December 19th. Earth closest, final measurements, last observations. Then farewell, 58 kilometers per second, never slowing, never stopping, never returning. One pass, one chance, one opportunity. We took it. Every telescope, every instrument, every wavelength, every technique. 5 months of observations, decades of analysis ahead, papers publishing, data sharing, understanding growing. But 3I gone. Back to the dark, back to the cold, back to the ancient orbit, thick disk wanderer, 7 billion years traveling, 7 billion more ahead, between the stars, alone. Silent, cold, until maybe another system, another species, another moment of light. Arcshiv preprint, July 7. From a different star, 3I Atlas in context of Otautohi Oxford model. Accepted, published, validated. Oppitum paper, VLT Muse spectroscopy. July 7. Monthly notices, Royal Astronomical Society. Letters, accepted, published, impact immediate. Seligman study. Discovery announcement, Archive, peer review, acceptance, publication, science proceeding, knowledge advancing, understanding deepening, 3I revealing secrets, slowly, partially, incompletely, but revealing each spectrum, each image, each measurement. One more piece, one more clue, one more answer, generating 3 more questions. More spectra, more measurements. November data crucial, December data final, then analysis, then models, then papers, then understanding. Maybe, or maybe more mystery, more questions, more hypotheses, more observations needed. Science proceeding as always. One step, one measurement, one paper. Slowly approaching truth, never quite reaching, always refining, always improving, always questioning. Dark object appears small, bright object appears large, reflects 4% sunlight, similar to asphalt. Dark surface, organic rich, carbon compounds, irradiated materials, billions of years cosmic ray exposure, surface modified, original composition masked, subsurface pristine. Coma reveals interior, outgassing exposes depths, spectroscopy samples nucleus, not surface, interior, formation composition, parent disk chemistry, thick disk signature, 7 billion years preserved, frozen in time, until now, until sun heats, until volatiles sublime, until secrets release. Into space, into instruments, into data, into knowledge. Of all possible orbital inclinations, 175 degrees occurred. 5 degrees from ecliptic, nearly perfect anti-alignment, backward through planetary disk, against the flow, opposing motion, maximum relative velocity, maximum encounter energy, maximum observational challenge, and maximum scientific value, because different, because rare, because unexpected, because forcing questions, because demanding explanations, because refusing easy categorization, not quite fitting models, not quite matching expectations, not quite behaving predictably. Exactly what science needs. Exactly what advances understanding. Exactly what 3i delivers. 3i departing. Last measurements. December 31st, final spectrum, final photometry, final astrometry, position confirmed, velocity confirmed, trajectory confirmed, escape verified, then silence, archives searched, old images examined, precoveries found, extended observation baseline. Improved orbit calculation, refined parameters, better predictions, more precise trajectory, but backward prediction limited. Can't trace to parent star, too much time, too many perturbations, too much mixing. Origin lost to billions of years. Only galactic population statistics remain. Thick disk velocity, thick disk age, thick disk chemistry. That's what we know. That's what measurements show. That's what survives 7 billion years. Uncertainty estimates, all public, all accessible, all preserved for future analysis, for improved models, for refined understanding. When next interstellar object arrives, when Rubin detects dozens, when statistics improve, when sample size grows, 3i becomes calibration, reference point. Comparison standard. First, retrograde aligned. First thick disk, first ancient wanderer. Future objects measured against 3i, similar or different, common or rare, expected or surprising. Building knowledge, one object at time, one measurement at time, one discovery at time. Until pattern emerges, until understanding deepens, until questions answered or new questions posed. Science continues, always continues, never stops, never finishes, never complete. Always more to learn, always more to measure, always more to understand. The revelation is ancient natural processes. 7 billion years, thick disk ejection, galactic orbit, countless stellar encounters, probability selection through vast time, billions of ejected objects, millions of random trajectories, thousands approaching solar system, hundreds passing through. Dozens detectable, 3 discovered, 3i the third, retrograde aligned by chance, or by physics, or by dynamics, or by selection effects, or by observation bias, or by statistical fluctuation, or by natural probability playing out over billions of years across billions of stars, generating billions of wanderers, until one arrives perfectly positioned to make astronomers question everything. That's the revelation. Not technology, not intent, not design. But nature generating patterns that look designed, statistics producing outcomes that seem impossible, time allowing rare events, universe big enough, old enough, active enough that 1 in billion happens. And we see it, and we measure it, and we question, and we learn. That's the revelation. That's what 3i Atlas retrograde trajectory truly reveals. That nature doesn't need intent to create precision, that physics doesn't need purpose to generate pattern, that mathematics describes reality without meaning, that we're watching universe unfold according to laws indifferent to our interpretations. Retrograde aligned interstellar comet from 7 billion years ago. Retrograde trajectory showing us exactly what needs showing, that we're still learning, still measuring, still questioning, still discovering. 3i Atlas, third interstellar object, first from the ancient thick disk, traveling 175 degrees retrograde through our planetary plane, teaching us that the most profound revelations come not from what objects are, but from what they force us to reconsider about what we thought we understood. Departing, 315 million kilometers from Earth, 2.1 AU, never closer again, trajectory calculated centuries forward, position predictable decades ahead, but instrument limits reached, light too faint, object too small, distance too great. 3i gone from view. Still there, still moving, still escaping, just invisible now, below detection threshold, beyond observation capability, into the dark between, where it came from, where it returns, where it belongs. 7 billion year journey continues. Next encounter unknown, next observation impossible. Next measurement never. One species saw it, one civilization measured it, one moment in cosmic time when Earth-based astronomers pointed instruments correctly and captured light from ancient wanderer making its only pass through inner solar system. We witnessed, we recorded, we preserved. That's enough. That's everything. That's what matters. 3i Atlas retrograde to the planet plane. What this reveals about its true nature, that nature needs no revelation, it simply is.